Hello, my name is Achyut Nyopane. In this video, we'll talk about design patterns in cloud computing. So let's talk initially about cloud computing. So it is an approach in which a third party provides software solutions to a company, and using the dedicated VMs, they run their applications on that one. So problem associated with this approach we resolve in design patterns. So let's look in first in multi-data center deployment design patterns. So in this design patterns, we deploy the application in multiple data centers. So why do we deploy it in multiple data centers? In case of failures in one of the data centers, you can retrieve your data from other data centers. So imagine a data centers in United States and Europe. So users in Europe can retrieve data from their data centers, and users in United States can retrieve data from United States data centers. So there is a significant network delay avoided. So in case of some of the failures, we can switch from one data centers to next data centers. So how can we do it? Either we can use round robin methods, or in case of fail, we can switch it to data centers, or based on the request as chip, we can redirect the request to the next data centers. So what is the disadvantage with this approach? Is like whenever there is a significant writing constantly in two different data centers, there is a chances of having inconsistencies between the data. Or like when you write to one DCs, then chances are that you cannot the data may not be available in next DC if you have not addressed the inconsistency between the data. So the scaling model, the scalability means whenever there is a need of more processes, you add the resources easily. So whenever a process uses more, whenever there are more resources assigned, it is a waste of resources, and whenever there are less resources assigned, it may be a bad customer response to that one. The way to achieve scalability is we regulate and we look at the CPU uses. If the more than 80%, then we assign a new VM, and if it is less than 40%, they can assign a next VM, or they can look at the traffic in the DCs and you can assign a VMs based on that one, or they can regulate, you can monitor the peak hours and down hours, and they can automatically assigns the VMs based on that one. So disadvantage with this approach is that it is not quite fast. If there is a significant traffic in 10 milliseconds, there is no way we can regulate it, because to bring up a new VMs, it has to load all the softwares, it has to reboot it, and it has to load the applications in that one. So there is a significant delay in that one. Another design patterns to reduce the time of response will be creating a direct association between client and servers. So when the client servers when a client try to access a resource from the DB in the servers, when it has to go to the applications, and if application wasted significant portion of time in processing and a significant process of time in network latency achieving, then we can avoid this using client and resource direct association. So the users so web applications, the users can request the web applications, and web application will provide ID, and that ID, using that ID, they can access the DB. So the disadvantage will be that when there is a very secure applications, when there is a high level of security needed, then you need to protect the data. So encryption and SSL has to be maintained for the high secure data. Asynchronous messaging design pattern. So in this pattern, our task is broken down into multiple tasks, and all the tasks run at the same time, so that when the task is completed, the users get messages based on the completion of all tasks. So let's see about over here. User puts a request for a topic, and tasks A, tasks B and tasks D are broken down based on topic. All tasks are performed by the web applications and they get a response, and aggregating all the messages, the users get a the required result. Starting, it is a design patterns beneficial for data scalability. So in this approach there is a schema, and that schema is replicated across multiple data centers, uh, and whenever there is a long list of data, then you can retrieve all the data based on the different instances from the databases. So let's look one model. So here is, imagine there is a customer, and customer has a long history for 10 to 30 years, and he want to achieve all the requests. Initially the application will put a request for the query, and query 3 will request some record from SAT1, query 2 will request some record from SAT2, and query 4 will require some request from SAT3, and when final query is formed, it will aggregate all the results and give to the users. And here are the available resources. Hope you enjoyed. Thank you.